Imagine a satellite so small you could basically fit it in a shoebox. Now imagine its mission is to catch the most violent, most spectacular events in the entire universe, right as they happen. Yep, we're talking about a tiny cosmic detective on the hunt for the biggest explosions out there.
But, that makes you wonder, right? Every single night, the sky above us is just filled with these incredible explosions, flares, and flashes of light that we completely miss. So what are these invisible fireworks, and why on earth have we been missing them all this time?
Well, it turns out the answer lies in our cosmic blind spot. There's a whole drama unfolding up there in the night sky that even our most powerful telescopes are completely, utterly missing. You see, the night sky isn't this peaceful, static thing we sometimes imagine. Oh no. It's a super dynamic, ever-changing stage for what astronomers call transient events. We're talking stars exploding as supernovae, powerful flares erupting from their surfaces. These are cosmic fireworks that can flare up and then fade away in, well, the blink of an eye. And here's the real kicker. A huge number of these explosions blast out their very first, most crucial light in the near-ultraviolet, or NUV, part of the spectrum. And our atmosphere? It blocks that light completely. So if you want to see this transient sky, you've got to go to space. So the obvious question is, why not just use a beast like the Hubble Space Telescope? Well, think of Hubble as an incredibly powerful telephoto lens. It can give you a breathtaking, detailed photo of one single distant galaxy, but its field of view is tiny. Plus, it's so sensitive that it actually has to avoid the brightest, most crowded parts of the sky, like the plane of our own Milky Way, so it doesn't fry its detectors. It's just not the right tool for the job. And this is where the hero of our story comes in. The solution to this giant problem isn't another giant telescope. Nope, it's something much, much smaller. Everybody, meet NetX, the near-ultraviolet transient explorer. It's this brilliant, compact, and super cost-effective cosmic detective. And it was designed specifically to fill this gap and stare right into the bright parts of the sky that other telescopes have to shy away from. Now, NetX is what's known as a CubeSat. And these things are amazing. They're tiny satellites built from standardized, almost Lego-like units. And because they're so small, affordable, and you can build them really quickly, they are absolutely changing the game for space science. Just how affordable are we talking about here? I mean, to really get it, you have to understand what a more traditional big space mission costs. It's kind of mind-blowing. Okay, so for perspective, let's look at a proposed mission called UVEX. It's a much bigger spacecraft designed for deep ultraviolet observations. Its estimated price tag? Over $300 million. Now compare that to NetX. The entire mission costs around $500,000. That is just an incredible drop. This kind of cost-effectiveness is what we mean when we say it's democratizing space. It allows universities and smaller teams to get in on doing real cutting-edge science.
But don't let that small price tag or its tiny size fool you. NetX punches way above its weight. As you can see here, it's just a tiny fraction of the weight of missions like WUVEX or UltraSat, yet it has a comparable field of view, and crucially, it's designed for a job the others aren't, a wide-field survey of the bright sky. Alright, so this little satellite is a total game changer. But how on earth do you pack so much science into such a small package? Let's pop the hood and take a look.
So inside, the design is just simple and brilliant. It's a type of telescope called a Ritchie-Chrétien. Light comes in, it bounces off a 146mm main mirror, then it hits a smaller secondary mirror. After that, it passes through two little corrective lenses before hitting the detector. It's all about maximizing every single photon of light you can collect. And the whole thing is held together by this really cool, open, modular cage. So instead of a heavy, solid tube, this design is super lightweight, incredibly strong, and it makes it way easier to put together and align all those sensitive optics. This is one of the key innovations that keeps the total weight down to just 4.3 kilograms. And this chart breaks that weight down for you. You can actually see that the mechanical structure, that cage and all the mounts, makes up more than half the satellite's mass. The optics and electronics make up the rest. It's really a testament to the kind of precision engineering you need to hold everything perfectly still in space. And now for my favorite part. At its electronic heart is something you might actually recognize. The whole processing unit is based on a Raspberry Pi. Using affordable, off-the-shelf stuff like this is a huge reason why new techs can be built so cheaply. It's just a perfect example of how this CubeSat revolution is making space science accessible to more people.
Okay, so we know how it's built, we know why it's so innovative. Now let's get to the really fun part. What exactly is NewTek going to be looking for out there in the cosmos?
Well, NewTek is a survey tool, right? It's designed to scan the sky and catch these fleeting events. This means catching the very first flash of UV light from a supernova, which can tell us what the star was doing just moments before it blew itself apart. It'll also hunt for these super powerful flares on small M-dwarf stars, which could tell us a lot about whether planets orbiting them could be habitable. And it'll look for the UV afterglows from insane events that produce gravitational waves, giving us a much more complete picture of those cosmic collisions.
So this is a map of flaring stuff that a previous mission called GALEX was able to see. Now NUTX will be able to spot many of these, but more importantly, it's designed to survey the bright plane of the Milky Way. That's the crowded band right across the middle. This is a region just jam-packed with potential discoveries that other, more sensitive telescopes have always had to avoid. It's basically unexplored territory.
You know, NASX is part of a much bigger trend in space science. It's not just a cool one-off mission. It really represents a fundamental shift in how we're exploring the cosmos. We are living right in the middle of a CubeSat revolution. Seriously, missions that used to take a decade and hundreds of millions of dollars can now be developed in just 2 or 3 years for a tiny fraction of the cost. And with NewTek scheduled to launch in the second quarter of 2026, we're seeing this new era of fast, agile space science happening in real time.
So NewTek is more than just a telescope. It's a pathfinder. It's blazing a new trail for space exploration. It's proving once and for all that massive scientific discoveries don't always need massive budgets or massive satellites. It's creating a whole new model for how more focused, rapid, and accessible space missions can be done in the future.
And all of this leaves us with a pretty fascinating final thought. This one mission is going to open a whole new window on the universe. But if one tiny shoebox-sized satellite can unlock these kinds of cosmic secrets, just imagine what a whole fleet of them all working together could discover next.